Hi, my name is Matthew and I'm a rising junior at Thermos Upper School. For my project I built the water filtration system, and this is my final video with my first milestone, my second milestone, and my modifications. So for my first milestone I have the biosand filter, which is responsible for the removal of turbidity, heavy sediments, and other dust particles. The way this works is in the materials inside of the apparatus itself. The large gravel, the small gravel, and the pool sand filter. All of these materials are in both the 4-inch in diameter PVC and the 3-inch in diameter PVC, where it connects to a brass elbow with a valve where the water is actually expelled into a new bottle. For my second milestone, I have the electrochlorination system, which just contains a diffuser plate, which prevents debris from destroying the two electrodes, a titanium mesh, and a mixed metal oxide known as ruthenium. And these electrodes supply an electrical current, which is powered by this 12-volt battery, to help to produce chlorine and sodium hypochlorite through the electrolysis of salt water. The electrolysis occurs in the 5 times that the salt water is poured through here, and there are 2 different reactions. The first reaction is the 2 moles of water and the 2 moles of salt and the 2 electrons from the 12-volt battery produce chlorine, hydrogen, and sodium hydroxide. Since you keep pouring it in 5 different times, a second reaction occurs where the products are chlorine, sodium hypochlorite, and water. Once this solution is produced, you add 10 drops into the water after it goes through the biosand filter, and here I have all of the tests. So this is the water before going into the biosand filter, water after the biosand filter, and the water after being chlorinated. So as you can see, this is much dirtier. This is pretty clean, and this is a lot more clear. And if you can't tell that in the camera, there is tested with a water tester which displays ppm values. And since the water tester only goes from 0 to 1,000, this has not even been tracked. Well, this was 470, and this was very good 120. So the lower the better. For my modification, I built a PIR motion sensor connected to a NeoPixel strip, which lights up when it detects motion, and in this case the motion is the flow of water. So this motion sensor is connected to a breadboard because there is a shared power supply, and connected to an Arduino, which I programmed to, whenever the motion sensor senses a motion, it would illuminate these NeoPixels. Some challenges I faced with this project were mainly in the biosand filter and in the modification. The biosand filter, I had some leakage because I did not apply enough PVC cement, purple primer, and adhesive to the places where I bolted and connected reducers. And eventually some pieces fell off because of too much applied pressure. And with my modification with the Arduino, my program was a little bit too complicated for it to process, and I had to simplify it down to one if statement as opposed to multiple if statements, and that fixed the problem. I really enjoy this project because, as I've seen many different countries have problems with actually getting clean water that is potable, I wanted to try and find a solution that can actually help people. It was very cool to actually try and create a solution that's not very expensive and that everybody can actually use. I also like this project because it really helped me boost my confidence in different arenas of engineering, such as mechanical, electrical, electronics, and programming.